This question that we have is a simple application of the Newton's laws of cooling. Whenever you see changes in temperature related to time, think about Newton's law of cooling. So the Newton's law of cooling states dt upon dt is equal to minus Ka into T minus T of surrounding. Let this be T naught. So we know this as the Newton's law of cooling. Now we have been given that a body's temperature falls from 40 degrees Celsius to 35 degrees Celsius in 10 minutes. We need to find out how much more time is taken for it to fall from 35 to 30 degrees Celsius. So we need to find out the time for this change given the time for 40 degrees Celsius to 35 degrees Celsius change. Now for solving this question, we can take this to be equal to the average rate of decrease of temperature, that is 40 minus, that is final minus initial. Change is always final minus initial. So 35 minus 40 upon the time taken, that is equal to 10 minutes. This is equal to K into A into T minus T naught. That is, now since the temperature is not constant throughout, therefore we take T average is equal to T. Therefore the T is equal to T average is equal to initial plus final by 2, that is 40 plus 35 by 2, that is equal to 37.5. Now this is just a way to solve the question. There is another way which I will tell you later, but this gives you the approximate answer to a great extent. Therefore, since this temperature of the substance was not constant, we took this to be the average value minus the temperature of the surrounding, which is given to be equal to 20 degrees Celsius. From this we get, there was a minus sign here also, therefore we get 1 upon 2 is equal to Ka into 17.5, that is equal to Ka is equal to 1 upon 35 minute inverse. Now let us see this change. For this change, we know dt upon dt, that is the average rate of decrease of temperature. This can be taken to be equal to 30 minus 35 upon the total time taken, which we need to find out, that is T. This is equal to minus of Ka minus of, we know the value of K to be equal to 1 upon 35 minute inverse. So we put in 1 upon 35 over here into T minus T naught. Since the temperature of the substance is not constant, we again take this to be the average value between this and this, so that we can assume the object to be at its average temperature of 32.5 degrees Celsius. Therefore we write this as 32.5 minus 20. So on solving this, we get the value of T equal to 14 minutes. So we get the answer for the time taken for the temperature of the object to fall from 35 degrees Celsius to 30 degrees Celsius, that comes out to be 14 minutes. Now there is another way to solve this question. If you do not want to make this approximation by taking averages, you can use this method. This dt upon dt is written to be equal to minus of K into T minus T naught. Now let us bring T minus T naught to the left side. This gives us minus K into dt. Let us integrate this and this from initial time 0 to T, and this from T initial to T final. Now this becomes ln of T minus T naught, that is T final minus T naught upon T initial minus T naught. This is equal to minus Ka into T. Now this is equal to delta T final, that is the final temperature difference between the object and the surrounding. This is equal to delta T initial, that is the initial temperature difference between the object and the surrounding. Always remember this delta Tf, we have defined it to be equal to the temperature difference, initial temperature difference between the object and the surrounding. Now we can write delta Tf upon delta Ti is equal to e raised to minus Ka into T. A is the surface area of the object. Therefore delta T final is equal to delta T initial into e raised to minus Ka into T. So we get this equation. let us use this equation now to solve the question. We have delta T final is equal to delta T initial into e raised to minus Ka into T. Let us apply this equation for the first case. For the first case, the final temperature difference between the object and the surrounding was 35 minus 20, because the final temperature was 35 is equal to initial temperature difference, that was equal to 40 minus 20 into e raised to the power minus Ka into time was 10 minutes. From this we get 15 upon 20 is equal to e raised to the power minus Ka into 10. Taking logarithm on both the sides, we get ln of 3 by 4 is equal to minus Ka into 10. Therefore, we get the value of Ka is equal to ln of 4 by 3 upon 10. We remember this now and solve for the second case. For the second case, again we use the same formula. Delta Tf is equal to delta T initial into e raised to minus Ka into T. Now, finally the temperature is 30 degrees Celsius, so the final temperature difference is 10 is equal to initial temperature difference, that was equal to 15 into e raised to the power minus Ka into T. From this we get ln of 3 by 2 is equal to Ka into T, which we need to find out. We know the value of Ka already. If we substitute it here to be equal to ln of 3 by 2 is equal to ln of 4 by 3 upon 10 into T. Therefore, T is equal to 10 into ln of 3 by 2 upon ln of 4 by 3 minutes. On solving this, we get the value of T to be equal to 14.096 minutes. So we see that the final answer that we get in the two cases is not very much different. In the from the previous method, we got the answer as 14 minutes, and from this method we get the answer as 14.096 minutes. So both the methods are correct. You may use whichever one you like to be easy. So our final answer for this question comes out to be 14.096 minutes.